Hi students, now we are going to solve problem number 11. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find the speed acquired and the distance travelled. What hint is given at the beginning of the sum you see here? A bus starting from rest means what is given? Yes, its initial velocity u is equal to 0. Okay. Then its acceleration is given in SI unit. That is direct 0.1 meter per second square. And the time taken is given in which unit? Minutes. So we have to convert it into second. And the quantities we have to find are the speed acquired and the distance travelled. You must be thoroughly knowing by this time that when the body is moving along a straight line, that is in rectilinear motion, distance and displacement both are one and the same. Like that, speed and velocity both are one and the same. So you must be very thorough that here the velocity acquired, that is the final velocity of the bus, is asked. Understand? And second, the distance travelled. So in this type of numerical problems, we are going to use the equations of motion which we have learnt earlier. There are three equations of motion. The first equation, that is velocity time relation, that is v equal to u plus at. The second equation is displacement versus time relation, that is s equal to ut plus half at square. And the third relation, that is v square equal to u square plus 2as. So using these equations we can solve this type of problems. So now what are the given quantities? I will write. So the initial velocity is equal to 0 because the bus is initially at rest. Next, the acceleration of the bus is 0.1 meters per second square and the time taken is equal to 2 minutes. So 2 into 60 seconds. So this is 120 seconds. And in the subdivision 1, what is asked here? Find the speed acquired. So the final velocity v is to be determined. And in the second subdivision, distance travelled s has to be determined. So in any numerical problem, you have to read again and again till you understand what is given and what has to be determined. Okay students, now we want to find out the final velocity. So for that we are going to use the first equation of motion, that is v equal to u plus at. What is the value of the initial velocity u here? It is 0. So this is 0 plus acceleration is 0.1. So this is 0.1 multiplied by t. The time taken t is 120 seconds. So this is into 120. So this must be equal to what? 0.1 multiplied by. So this is 0.1 multiplied by 120. I can split as 10 into 12. Am I right? These are some easy steps, that's all. So those who are good at mathematics can directly multiply and write the answer. So 120 is split as 10 into 12. So that this 0.1 into 10 is what? 1. So this is 1 into 12, that is equal to 12. Okay. Therefore, the velocity gained by the body or the final velocity of the bus is now equal to 12 meters per second. This is the answer for the first part of the problem. Find the speed acquired. I told you along a straight line motion, speed and velocity both are one and the same. Okay. Now what is next? The distance travelled. So in the second subdivision, for the second subdivision, we can use s equal to u into t plus half a into t square. So initial velocity is 0 plus 1 by 2 into acceleration is 0.1 into t square. T square is 120 into 120. So Now half into 0.1. So this can be written as half into 0.1 into this 120. I will split once again as 10 into 12 into 120. So this 2 and 120 can be cancelled 60 times. 60 into 2 is 120. So what are the remaining factors? Now 0.1 into 10 is how much? This is equal to 1. Is it not? So this is 1 into 12 into 60. 12 6 are 72 into 10 is 720. Therefore the distance travelled is equal to 720 meter. So this is the answer for the second part of the problem. So the speed acquired by the body in 2 minutes is v equal to 12 meter per second, and the distance travelled by the body in 2 minutes is equal to 720 meters. I hope you must have understood well. Fine.